Welcome to this module. This is module number 3 for our lecture 1 for fabrication techniques for MEMS based sensors clinical perspective. So, until now we have seen several sensors, right, and we have also talked that how these sensors can potentially solve an important problem in medical diagnosis or in clinical research. So, let us see in this particular module some other sensors, right, and let us understand that how we can use our understanding of microengineering and technology to fabricate those sensors. Now, a very important point that is there right now, or a very important disease, or you can say the most prevailing disease is diabetes, right. And we have seen that for understanding the blood glucose level concentration, right, what we have to do? We have to puncture the finger, and then we have to put a drop of blood on the glucometer to understand the blood glucose concentration. Now, this is minimally invasive technique because you are puncturing your body. How about you find a non invasive way? That means, without puncturing your body, can you detect diabetes? Or a matter of fact is, can you detect any disease? Can you diagnose any disease without puncturing your body, right? And that is a better technology which can facilitate a person to go to a doctor and not worry about puncturing the body, right. You have feel that pain of needle going into your veins, right. So, you assume that every time you want to measure the blood, you have to puncture your finger, and it is painful, right. So, what is that alternative technique? What is that alternative technique? And that is that we can detect the, or we can diagnose the particular disease from the concentration of the gases that we exhale, right. We inhale, we exhale. So, when you exhale from a patient to patient, from a person to person, there are several VOCs that we exhale along with the things that we already know, which is carbon dioxide, right, CO2. But along with CO2, what else or what other VOCs we exhale? Now, when I talk about VOC, what does VOC mean? VOC means volatile organic compounds. So, when you say volatile organic compound, what does that mean? Organic compounds that are volatile. Can you give me example? One example, VOC. Think about organic compounds that are volatile, right. Have you thought about it? Is it petrol? Is it diesel? Is it ethanol, right, alcohol? Is it acetone, butanol, butanol, isopropyl alcohol, right, kerosene? So, all these are volatile organic compounds. That compound, suppose I take a drop of petrol and I put a drop of petrol on the table, what will happen? It will evaporate, at room temperature, volatile, right. So, when I talk about ketones or alcohols, right, then certain amount of this VOCs we exhale in our breath, and the concentration of VOC changes if a person is suffering from a particular disease. So, if we can selectively delineate, separate out, delineate that particular VOC from the group of VOCs from the breath of a person, then we can have a non invasive way of diagnosing a particular disease, is not it, right. So, exciting field of research, right. So, how can we do that? How can we do that? Now, you see we are blessed to have lot of sensors, we are blessed to have lot of sensors. If you think about my hand, right, I can feel it, I can feel the surface, I have touch sensors, I have force sensors, I can understand how much force I am applying, right. Then sound, then taste sensors, then optical sensors, then nose, smell, right. Just to name few, there are thousands of sensors within our body, right. So, now if we have this many sensors, let us take from one of the idea that we already know, and that is our nose. So, let us see this. If I blindfold myself, so I cannot see, right, and I put something on my ear, so I cannot hear, and I cannot taste, right, I put a tape on my mouth, right, and I cannot touch, only thing is I can smell, alright. And if there is a lemon, that is a cut lemon or orange, can I distinguish just by smelling lemon and orange? And 90% of people can, 90% of people can. How? By smell, right, by smell. That means there are sensors within our nose in a form of array, and that sensors gives us the sensitive data, that is okay, this is the concentration so and so, right, or at least qualitative analysis, right, that this is the smell of lemon, this is the smell of orange. But how we process this, how I can distinguish between just by smelling lemon and just by smelling orange, right. So, you further understand that now how our nose functions. Is our nose connected with some other part of our body? And you will say yes, it is connected with your brain, right. That means brain has that pattern that whenever nose gives you that particular smell, it has a signature that immediately tells you okay, this is a smell of lemon. That means our nose is connected with your brain, or with our brain, right. And that means that if I want to mimic this same function in forms of sensor, because you see a nose, right, there are so many sensors within the nose, all are micro sensors, so small, even nano sensors. So, if I want to design a nose using my micro technology, what we can call it is an electronic nose, it is an electronic nose, or it is an e-nose, right. Now, in our body, our nose is connected to brain, here also we need to connect the nose to brain, which is your artificial neural network, or we need to understand or recognize the pattern, that is why pattern recognition, right. So, you need to design the sensor, you need to fabricate those sensor, you collect the data by inserting or you put the sensor in a chamber and let different VOCs pass through the chamber, and you collect the data. Once you have a good amount of data, you can train your neural network, right, and then you can test it. Now, it looks so simple, it is not, because now there is a factor of humility, right. But if you study well and if you understand, then the research articles, the literature says that the person suffering from diabetes will exhale a higher concentration of acetone compared to other volatile organic compounds. So, what does that mean? That from that VOCs that we exhale, the person suffering from diabetes will exhale acetone in a higher concentration, that our sensor should sense it. Now, not only it has to sense it, but it has to selectively delineate from the group of other VOCs, from the group of other volatile organic compounds, right. So, can we design this sensor? Can we design this sensor? So, that when you want to design this kind of sensor or group of sensors, right, you should know microengineering, you should know microtechnology, all right, and you can design this array of sensors. Of course, you can design array of sensors which are bigger in dimension, larger in dimension, but for the smaller sensors, for the micro, for the nano sensors, you need to go through this particular technology. Okay. So, when we say that generally you see the effect of pollution on our health, air pollution, right, water pollution, soil contamination, it causes several things. For example, if you see the air pollution cause, what are air pollutions? Carbon monoxide, particulate matter, ozone, right, lead, SO2, NO2, NOx, VOCs, volatile organic compounds. So, we are in this particular category, we have to see this particular group. Water pollution, we are talking about bacteria, parasites, chemicals. I was talking about antibiotic resistance in the last module, right. And what does this VOCs affect to which kind of organs? You see, respiratory illness, it causes cardiovascular illness, and just not VOCs, but in the total air pollution. But if you just talk about VOCs, it causes cancer risk, nausea, skin irritation, right. This is harmful, these are cases are harmful. You see, it clearly states that VOCs can cause cancer, can cause cancer. So, if you have seen a newly painted wall, then that will smell differently, and people should not go for a newly painted wall, because it will emit VOC, it will emit VOC. Okay. So, now VOC sensing is very important, and you can also sense other gases. So, there are two techniques that we will learn in this particular course. One is called VOC sensor that can sense volatile organic compound. Second is called gas sensor that can detect various gases, all right. So, we will see how we can design this VOC sensor or gas sensor using microfabrication. As I stated, VOCs are found in individual's breath in hundreds of ppm range, and only a small VOCs are common to everyone. The concentration of VOCs exhaled by patient for different disease is different than in the healthy person, right. So, VOC sensing is important in environment monitoring and in medical diagnosis, very important, right. So, when you talk about VOC, we have to see sensors, and right now in front of you, you can see two types of sensors. Sensor 1 here, and we will see in detail how we can fabricate this sensor. This sensor is fabricated using bulk micromachining, all right. While you can see sensor 2, which is this particular sensor, this is used or fabricated, this is used for detecting VOCs, and it is fabricated using bulk plus surface micromachining, bulk plus surface micromachining, all right. Sensor 1 is fabricated using bulk micromachining, and we will see how we can fabricate this particular types of sensors that can be used for detecting volatile organic compounds, or it can be used for detecting gases, all right. And of course, the main part of the sensor is the sensing film. Here you can see we have used indium tin oxide, here we have used zinc oxide, and you can use several metal oxide semiconductors, or you can say conducting semiconducting oxides or semiconducting oxides, metal oxide semiconductor or semiconducting oxides, all right. There are several kind of semiconducting oxides, and how this sensing works we will discuss in detail when we talk about the sensors sensor in the following lectures. Now, if you talk about a flexible force sensor or flexible sensor, right, you need to design first flexible sensor and you to know what kind of substrate I should use, so that my sensor will not crack or it will not get destroyed. So, I would like that even it is not really important or necessary for a microengineer to learn the schematic tools, particularly if you talk about Pro E or SolidWorks or CATIA, right. It is always good to learn, right. Most of us, when we study electronics or electrical engineering, right, we kind of ignore the design, and design is very important aspect in fabricating any equipment, including sensors. How well you can show your schematic representation, because that will help not only the person who is fabricating, but also it will help for a person who is understanding reading the literature, right. So, if you want to fabricate a flexible force sensor, let us see the design on the screen right now. What we can see, if you see this particular sensor, this sensor consists of, the sensor exactly is in the center here, right, or you can see this is the magnified view of this particular image here. So, if I can show you what magnification we have used, we have magnified this area. So, what you see? You see few sensors here, still it is difficult to see, right, still it is difficult to see. So, we have further magnified this area, now it is little bit better, right. What does it has? It has a strain gauge, alright, it has a strain gauge. Let me draw a little bit big strain gauge, so that we understand. Okay. And this strain gauge is made up of piezoresistive material. We can use conducting polymer P dot PSS. On this strain gauge there is insulator. What is that? There is insulator. On the insulator there is an electrode. Okay. I am just making it thicker, so we know electrode. Okay. Mind that there is an insulator between the strain gauge and the electrode, alright. Now, insulators have the strain gauge has how many points? It has 2 points, right, it has 2 points, 1 and 2, electrode 1 point, you get it. This is what you can see in this particular image. You see this one, or you see this one, or you see this one, or this one, or this one. There are 3 points going out, 1, see 1, 2, and the pink one is your third one. 2 from strain gauge, 1 from the electrode. On this electrode we have, so there is a electrode, right, in center there is a electrode, and this electrode is made up of gold, alright. Strain gauge I told you P dot PSS, and this is the flexible substrate. That is why you can see here 3 pads, 1, 2, 3, right. There are 3 pads. These are contact pads for the sensor, So, what you will do with this flexible force sensor, right? We can connect these flexible sensors on the robotic arm, we can connect on a surgical device, we can connect this on a catheter, we can connect this particular sensor with a 3D printed cone to measure the property of a material, for example elasticity of the material, to measure the electrical and mechanical property of a tissue, right. So, it has many applications, Now, if I want to measure, let us say this is the last slide of this particular module, and you can see what you have a housefly, right, and housefly is sitting on what? Housefly is sitting on a flexible sensor, it is sitting on a flexible sensor. So, you can see that there is a sensor at the bottom and there is a cube here, you can see this cube, right, on which the housefly is sitting, all right, and we want to measure the weight of the housefly. We want to measure the weight of the housefly. Is our sensor sensitive enough to measure the weight of housefly, or what is the weight of a housefly, right. So, you can see this is an SEM image of a housefly, and of course, the fly is dead, otherwise it will fly. So, this housefly is dead, right, and we have placed the housefly on the sensor, all right. So, without housefly and with housefly we can see the change in the resistance of this particular sensor, and from that we can correspond that what is the weight of a housefly or how good our sensor is. Before we can measure the fly, we have to first characterize our sensor, right. We have to compare it with the commercially available sensor and see that how it responds to different force, right. And in fact, when you really observe the tiny things flying around us, right, we generally do not care. If there is a housefly, we kill, if there is ants, we kill, right, if there are ants, we just kill. But have you ever thought that such a small thing is flying all around, how beautiful the structure may be? What is the structure of the housefly, right, how it can see, how it can feel? Are there sensors on the housefly, right? When you really try to observe these small tiny beautiful things in nature, of course, I do not say that you should have a lot of housefly in home, but I am just asking you to appreciate the beauty of the smaller structures, smaller insects, smaller organisms around you, and really understand that how beautiful the nature is, and from that design of the nature we can get lot of ideas for designing our sensor, right. This is all inspiration, you can see it is so tiny and still it can do so many things with its small structure, isn't it? Isn't it beautiful when you see in SEM? So, anyways, the point is not to just appreciate the beauty that nature has, but also to understand the design that nature gives us, right. When you really understand the design of the nature, you can implement it in your sensors, and that is how we can come up with novel design of sensors that can help us in solving a very important problem in clinical domain. All right. So, with this line we will stop the this particular module, and we will see in the next module, in the next lecture in fact, that how we can fabricate a particular sensor. And to understand fabrication, we should understand lithography. But before we move on to lithography, we will first see what do you mean by bulk and surface micromachining, right. So, I will see you in the next class. Till then, you just look at the sensors that we have been discussing in all three modules, and now we will go on to understand how we can fabricate these sensors and what is the application of each of those sensors. All right. Till then, you take care, and I will see you in the next class. Bye.